Okay, dear students, very good morning to all. I am P. Rajesh Kannan, Department of Chemistry, Swami Vivekanandar Matriculation Higher Secondary School. Okay, now we are discuss about that one of the new topic about that S block elements. We are already known that S block elements. What is mean by S block element? The last electrons are goes to which the orbital. That based elements we are classifying this of four types. We know that S block elements, P block elements, D block elements, and then F block elements. Okay, the last electrons are goes to ns orbital mean that block elements we are called as an S block elements. We know that S block elements are present in beginning of the periodic tables. Okay, the first group and then second group elements we are called as an S block element. Okay, the first group and then second group elements. Okay, the first group elements we are called as an alkali metals. Okay, what are they? Hydrogen, lithium, sodium, potassium, rubidium, cesium, and then francium. These are all we are called as an alkali metals. Alkali metals. They are all. What is mean by alkali metals? They can be produced the base. So there is a base producer. So we are called as an alkali metals. Then second group elements. What are they? Lithium, beryllium, magnesium, calcium, strontium, barium, and then radium. These are all we are called as an alkaline earth metals. It is also they can produce the base, but mostly we are obtained from this our earth crust. So we are called as an alkaline earth metals. What are the alkaline earth metals? Lithium, beryllium, magnesium, calcium, and then strontium. These are all we are called as an alkaline earth metals. Okay, the first group element and then second group elements we are called as an S block elements. The first group elements we are called as an alkali metals. The second group elements we are called as an alkaline earth metals. Okay, the last class we have discussed about that. What are the alkali metals? What are the alkaline earth metals? What are the properties? Physical properties of alkali metals and then alkaline earth metals. Okay, today we are discuss about what are the important chemical properties about that alkaline metals. Okay, now we are discuss about only the what are the important chemical properties about that alkali metals. Okay, we know that among that all the elements and then alkali metals and then alkaline earth metals, especially that is a S block element, it is a highly reactive elements. We know that. Okay, they are all easily react with this another element. So these are all we are called as a highly reactive elements. Okay, that is highly reactive metals. Okay, now compare that of the periodic table they can be consist of 18 group. Okay, that 18 compare that of 18 to 18th group element. Okay, the first group element has this most reactive metals. Okay, the first group elements are all are the most reactive metals: lithium, sodium, potassium, rubidium, cesium. Okay, the francium is the radioactive elements. Okay, only we are discuss about up to the cesium. We cannot be considered for the francium because of the francium is the radioactive elements. Okay, radioactive elements. What is my radioactive element? Those the elements that it can be undergoes spontaneous disintegration, which result that emission of alpha, beta, and gamma radiation. The finally they can produce stable isotopes. Okay, that is francium is the radioactive elements. Only can be discussed about up to the cesium. Okay, lithium to cesium only we are discuss about them. We know that these are all the highly reactive elements. Why these are all the highly reactive elements? Means that easily lose that one electrons from this outermost orbital. If they can be formed this a stable isotope electronic stable electronic configuration of that noble gases. Okay, for example, that is a lithium. They can be lose that one electron from this outermost orbital. It is comes into this neon electronic helium electronic configuration. The sodium they can be lose that one electron from this outermost orbital. It is comes into this neon electronic configuration. Okay, for example, we know that the sodium atomic number 11. It has 11 electrons and then 11 protons. We know that. Okay, that sodium they can lose that one electron from this outermost orbital. They can make a cation and liberate that one electrons. Okay, it has this 10 electrons. That is equal to the neon electronic configuration. So that alkali metals they are all easily lose that one electron from this outermost orbital. They can be make a electropositive ions. Okay, we know that the electropositive character is responsible for the metallic character. We know that the electropositive character is the responsible for the metallic character. So these are the strong electropositive metals. What are the lithium, sodium, potassium, rubidium, cesium, and then francium? These are all the highly electropositive elements. The tendency they can be lose the electron from this outermost orbitals. It has then possesses lowest ionization energy. Already we have discussed about in our that is a periodic classification lesson. Okay, we know that. Okay, which is the group among that all the group element, which is the group element have a lowest ionization potential? First group element have this lowest ionization potential. We know that among that all the element, which the element have a very low ionization enthalpy, very low ionization potential, mean the cesium have this lowest ionization potential. We know that because of the cesium have this biggest size. Okay, so the cesium have the biggest size. Okay, the size of the atom we know that increases means size of the atom is increases means the force of attraction between the center of the nucleus and the outermost orbital is decreases. So we can be provide that very minimum amount of energy. Okay, they can be easily remove the one electron from this outermost orbital. Okay, among that all the group element, which the group element have the biggest size? First group element have this biggest size. At the same time, among the all the element, which the element have this biggest size, mean the cesium have this biggest size. So that alkali metal exhibit the higher the chemical reactivity. The reactivity of alkali metals increases from this lithium to cesium. Okay, since that ionization energy is decreases as the down the group. All the metals are highly reactive towards this more electronegative elements such as oxygen and halogens. Okay, all the alkali metals are highly reactive towards this more electronegative elements such as the oxygen and halogens. Okay, among the all the group element, which one group element have this highest electronegativity value? Halogen, it has the highest electronegativity values. Okay, which one of the element if they can easily lose the electron, mean that is we are considered as a metals. Okay, which among the following one of the element they can easily gain the electron, mean that is we are considered as a non-metals. So metal they can be easily react with the non-metals, that is the meaning. Okay, that is highly electropositive element is combined with the highly electronegative element such as the oxygen and the halogens. Okay, then some characteristics of the chemical properties of alkali metals are now we are discuss about them. Okay, now we are discuss about some important chemical properties about that alkali metals. First we are discuss about the reaction with oxygen. Now we are discuss about the reaction with oxygen. That is alkali metals on exposure to air or oxygen bonds vigorously forming oxides on their surface. Okay, for example, lithium, sodium, and then potassium. We are already discussed about in our the lower sections. Okay, lithium, sodium, and then potassium. Only we can be placed in this under the surface of corrosion. Okay, why that it is a lithium, sodium, potassium? They can be placed in this under the surface of corrosions means they are all very highly reactive elements. They can be easily combined with this atmosphere air. They can be vigorously react with this atmosphere air. They can be explosively combined with this atmosphere air. So we are kept into this under the surface of the corrosion. Okay, we know that. Okay, so all the alkali metals on the exposure to air or oxygen burns vigorously forming oxides on their surface. Okay, the lithium forms only the mono-oxides. Okay, that is one of a very important one more question. Okay, all the students listen carefully. Okay, there is a this question is comes from this in our need. Also, listen listen carefully. Lithium forms only the mono-oxides. Okay, what are the lithium, sodium, potassium, rubidium, cesium? Okay, these are all the alkali metals. All the alkali metals are react with this oxygen. Okay, but lithium only produces mono-oxides. The sodium form this mono-oxides and then peroxides. The sodium form this mono-oxides and then peroxides. And the other elements form this mono-oxides, peroxides and then superoxides. Okay, with one more question, how they can be asking for that one more question for this area. Listen carefully. Which among the following one of the element or metal is react with oxygen, especially that is a alkali metal, react with oxygen, it forms this monoxide, lithium, sodium, potassium, rubidium, cesium. Okay, which is the metal? The lithium. The lithium only form this monoxides, do not form this peroxides and then superoxides. Okay, are you able to understand that? How they can be asking for that questions? Okay, which among the following one of the alkali metals only produce the monoxide within this oxygen, within the react with the oxygen. Okay, lithium. The sodium form this monoxides and then peroxides. Okay, which among the following one of that element form this monoxides and then peroxide, the sodium metal. That other element form this monoxide, peroxides and then superoxides. Okay, what are they? Potassium, rubidium and then cesium. These are three metals. What are they? Potassium, rubidium and then cesium. The three alkali metals are react with the air. It forms this monoxides, peroxides and then superoxides. Okay, these oxides are basic in nature. All the metal oxides are basic in nature. All the non-metal oxides are acidic in nature. It is also, that is a one of the one more questions. The metal oxides forms acidic oxides, basic oxides, neutral oxides. None of this. Okay, that based asking for that questions in our annual examination and then NEET examinations, JEE examination also. Listen here, the metals. Okay, the metal oxides. The metal oxides are basic in nature. Non-metal oxides are acidic in nature. Okay, for example, which one of that element react with oxygen? They can be produces oxide. That oxide is a basic nature. Okay, which is the metal? There is a definitely there is a metal oxides. The metal oxides they can be produces basic oxides. Okay. For example, listen carefully. Now we can be discuss about the lithium. The lithium react with oxygen. Lithium is the react with oxygen. They can be produces lithium monoxides. Lithium monoxide to Li2O. Sodium they can be react with the oxygen. They can be produces Na2O2. There is a peroxide. It is also they can be produces Na2O. The lithium or sodium also. That is a sodium also. They can be react with the oxygen. React with the oxygen. It can be produces sodium monoxide, Na2O. Okay, there is Na2O, 4 moles of sodium. They can be react with the oxygen molecule. They can be formed this 2 moles of 2 Na2O. Okay, they can be formed the sodium monoxides. This is nothing but sodium peroxide. Na2O2 is the sodium peroxide. What is the molecular formula for sodium peroxide? Na2O2. What is the molecular formula for sodium monoxide? Na2O is the sodium monoxide. So the sodium it can be produces sodium monoxide and then sodium peroxide. It does not make a superoxide. The sodium and then lithium does not make a superoxides. Okay. Then metals, other metals, what are they? Potassium, rubidium, cesium. They are all react with the metal. They react with the oxygens or atmosphere air. They can be formed this metal oxides. This is nothing but it is a superoxides. Metal MO2. There is a meaning is nothing but KO2, RbO2, cesium O2. These are all the superoxides. Okay, which among the following is a superoxide? Which among the following is a peroxide? Which among the following is a monoxide? Okay, how they can be asking for the questions? Okay, listen here. Which among the following is a superoxide? Which among the following is the monoxides? Okay, the lithium Li2O, Na2O, okay, K2O, Rb2O, cesium2O. These are all the monoxides. Okay, Na2O2, K2O2, Rb2O2, cesium2O2. Okay, these are all the peroxides. What are that? Superoxides, KO2, RbO2, cesium-O2. Then these are all that superoxides. Next we are discuss about the reaction with the hydrogens. Reaction with the hydrogens. Listen here that all the alkali metals they react with the hydrogen at above that 670 Kelvin to 1073 Kelvin to form this corresponding ionic hydrides. Okay, listen here. The different kind of the hydrides are there. Metal hydrides, covalent hydrides and then ionic hydrides also there. Metals are react with the hydrogen. Metals are react with the hydrogen. They can be produces metal hydrides. It can be known that a H plus ion mean we are called as a name protons. Okay, H minus ion we are called as an hydride ions. Hydride ions. The metals are react with the hydrides. They can produce metal hydrides. The reactivity of alkali metals within the hydrogen is decreases from this lithium to cesium. The reactivity of alkali metals. The reactivity of alkali metals, okay, with the hydrogen decreases from lithium to cesium. Okay, the metal combined with this hydrogen, they can produce metal hydrides. Lithium, sodium, potassium, rubidium, and then cesium. Okay, listen here. The lithium is vigorously react with this hydrogen. Okay, it produces lithium hydride, sodium hydride, potassium hydrides. These are all they can be easily form this metal hydrides. But the cesium, it has the same form this metal hydride within the very slow rate. That is the meaning. Okay, the reactivity order of metals in this within the hydrogens, okay, which that is a lithium have this most reactive. We compare that of sodium, potassium, rubidium, and then cesium. Definitely there is a one more question is asking for in our annual examination also. Listen carefully. Write the increasing order or decreasing order of the reactivity of alkali metals within the hydrogens. Okay, so lithium readily react with the hydrogen. We compare the top sodium, potassium, rubidium, and then cesium. Okay, the cesium very slowly react with this hydrogen. Okay, they can produce metal hydride. This is the order. Okay, it is a very important thing. Okay, the reactivity order of metals within the hydrogen. Okay, next we are discuss about that ionic character of hydrides increases from this lithium to cesium. Okay, that ionic character of hydride is increases from this lithium to cesium, and that stability is decreases. First we are discuss about that. Okay, the ionic character, the lithium hydride, sodium hydride, potassium hydride, rubidium hydride, and the last one is known as a cesium hydride. Which one they have this most ionic character? Okay, the cesium hydride. That the cesium hydride has the more ionic character. Which is the least stable? The cesium hydride is the least stable. Okay, among that all the one. Okay, this is the one more question. Okay, which among the following one of the metal hydride is most ionic character? Which among the following one of the metal hydride is the least ionic character or most covalent character? Okay, the cesium hydride has this more ionic character. Lithium hydride has the least ionic character. But the stability of metal hydride is the reverse order. Okay, that is the cesium hydride has the less stability. We compare that of rubidium hydride, and then potassium hydride, sodium hydride. Okay, among the following one of the metal hydride, which one they have this the highest stability? The lithium hydride has this the most stable. Lithium hydride is the most stable metal hydride. Cesium hydride is the least stable metal hydride. Okay, now we can be discuss about that why the lithium hydride is the most stable, why the cesium hydride is the least stable. Okay, we know that as the move the down the group, the size of the atom is increases. As the move the down the group, the size of the atom is increases. Now can be compare that to lithium, sodium, potassium, rubidium, and then cesium. Lithium has a very smallest size. Lithium has very smallest size. Cesium has this biggest size. That hydrogen also they have a very smallest size. Okay, that is a very smallest positive ion. It can be combined with this very smallest negative ions. They are all strongly binded to each other. Very strongly binded to each other. Okay, the strong force of attraction is exists between the lithium plus ion and then H minus ion. We cannot be easily break them. The large amount of energy they can be need for that breaking that lithium hydride molecules. So the lithium hydride is the most stable. Okay, that is thermodynamically most stable because they are all strongly bonded to each other. Okay, but the cesium ion has the very biggest size. That hydride ion have a very smallest size. Okay, that is the cesium ion. Okay, the cesium ion is very loosely binded with this H plus ions. Very loosely binded to the H plus ions. So the less force of attraction is exists between the cesium cesium plus ion and H minus ion. So we can be easily break them. So this is a thermodynamically least stable. Okay, the lithium hydride is a thermodynamically most stable. Okay, then another one of important thing, we know that Fajon's rule. What says that Fajon's rule? The larger the anion, smaller cation. Okay, which the compound has this larger the anion and then smaller cation, mean that compound is the covalent character. The compound has this most covalent character. Okay, listen carefully. This is one of the very important concept. Okay, the Fajon's rule. Okay, what says that Fajon's rule? Okay, which the molecule has this largest anion, smaller cation. It has this a covalent character, most covalent character. Okay, then reverse order. Okay, which one have this here? Smaller anion, larger the cation, it can be make that more ionic character. Smaller anion, larger the cation. Smaller anion, larger the cation. Okay, it is a very important thing. Definitely one of the one mark question asking in our annual examination at that same time. Okay, one or the two or three questions is asking from our NEET and then JEE examinations. Okay, this is the concept. Okay, if you can be thoroughly known this the concept, mean you can be ready to answer for that questions. Okay, which among the following one has this most ionic character, which one has this most covalent character, which one has the least ionic character, which one has this least covalent character. Definitely there is one question is asking from this in our JEE and then NEET examinations. So this is the concept. What says that Fajon's rule? According to the Fajon's rule, the larger the anion, smaller cation. Larger the anion and the smaller cation, means it has the most covalent character. Okay, and then smaller anion, larger the cation, mean that the compound may have this make a more ionic character. Okay, now compare the end of lithium hydride, sodium hydride, potassium hydride, rubidium hydride, and then cesium hydride. Okay, we know that here the size of the hydride ion is the common for all kind of that crystalline solids. Lithium hydride, sodium hydride, potassium hydride, rubidium hydride, cesium hydride. These are all the ionic hydride. There is no doubt at all. Okay, listen here. Which one has this most ionic character? Which one has this most ionic character? Now we compare lithium, sodium, potassium, rubidium, and then cesium. Which one have the smallest size? Lithium have a very smallest size. The lithium ion, okay, it is, we know that it is a positive ion. So the smallest cation. The cesium ion is the largest cation. Okay, according to the Fajon's rule, smaller anion, larger the cation. Smaller the anion, larger the cation. Okay, they can make a ionic compounds. We know that. Okay, those the compound containing smaller cation, smaller the anion, larger the cation, mean that the compound is known as the ionic compound. So this cesium hydride is the most ionic character. Okay, the reducing agent and the reducing nature increases as the down the group. Okay, these are all act as the metal hydride act as the reducing agents. Okay, the reducing agent and their reducing nature increases the down the group. Okay, listen here. Which one they have is the most reducing character? Cesium hydride has the most reducing character. What is mean by reducing agent? Those the agent, they can be easily lost the electron, mean that is they can be undergoes this oxidation. That is act as a reducing agent. Okay, what is the reduction? The removal of oxygen or addition of hydrogen to the component, mean that is we are called as a reductions. So there is metal hydrides, lithium hydride, sodium hydride, potassium hydride, and then rubidium hydride, last one is the cesium hydride. These are all act as a reducing agent. Here the cesium hydride, is the most reducing agent because of they can be easily produces a H minus ions. H minus ions enna பண்ணும் அப்படி பார்த்தீங்கன்னா ஈஸியாக ப்ரொடியூஸ் பண்ணும். ஓகேங்களா. ஸோ there is this cesium hydride is the most reducing agent. That is also there is one more questions. Which among the following one of the metal hydride? Lithium hydride, sodium hydride, potassium hydride, rubidium hydride, and then cesium hydride. Okay, which one have this a most reducing character? Cesium hydride. Which one the least reducing character? Lithium hydride has a least reducing character. Then next we are discuss about the reaction with this halogens. Reaction with halogens. Alkali metals combine readily within the halogens. The alkali metals are readily combined with the halogens to form this ionic halides. Okay, the lesson here: alkali metals combine with the hydrogens, they can produce metal hydrides. Alkali metals are combined with the halogens, they can be produces ionic halides. Okay, the reactivity of alkali metals within this halogens increases the down the group. The reactivity of alkali metals within the halogen is increases the down the group because of the corresponding decrease in the ionization enthalpy. Okay, this is the opposite for that, the reactivity order of hydrides. Okay, the metals, okay, react with the hydrides as the move the down the group is decreases, but here, okay, that is a metals react to the halogens as the move the down the group is increases because of the corresponding decrease in this ionization enthalpy. Okay, for example, the metal combined with the halogen, they can be produces metal halides. It is metal halides are nothing but these are the salts. Okay, there is a alkali metals are highly electropositive elements. The halogens are highly electronegative elements. Okay, they can be produces ionic compounds. These are all the ionic compounds. All the metal halides are ionic compounds. Okay, sodium fluoride, potassium chloride, rubidium bromide, cesium iodide, these are all are very good ionic compounds, we know that. Okay, the metals, for example, lithium react with the halogens, they can form this lithium halide. Sodium, it is combined with this halogens, it can produce sodium halide. Potassium, it can be combined with this halogen, it can produce potassium halides. Okay, the lithium, they can be react with the chlorine, it can produce lithium chloride. Okay, sodium, they can be react with the halogen molecules, they can produce sodium chloride. Okay, the rubidium bromide, cesium iodide. Okay, the similar manner. Okay, these are all that metal halides. All the metal halides are ionic crystals. We know that the ionic compounds are soluble in water, we know that. However, the lithium iodide shows that covalent character according to the Fajon's rule. What says that Fajon's rule? Larger the anion, smaller cation. We know that as the move down the group, fluorine, chlorine, bromine, and iodine. Okay, that iodine has the biggest size. Now compare that of lithium, sodium, potassium, rubidium, and then cesium. Okay, the lithium have the smallest size. So the smallest cation, the larger the anion, combined to form this lithium iodide. Okay, the 2 moles of lithium, it is react with 1 mole of iodine molecule, they can produce 2 moles of lithium iodide. This has a covalent character. Okay, according to the Fajon's rules. Okay, for example, cesium fluoride, cesium chloride, these are this most ionic character. Okay, the lithium iodide shows that covalent character as it is the smallest cation and then extract the highly polarizing power on the iodine ion. Okay, we know that lithium have a very smallest cation, we know that smallest positive ion, it has this a more polarizing power. Okay, so that is the smallest positive. நம்ம பார்த்துருப்போம் இல்லைங்களா, கடுகு செலுத்தாலும் காரம் குறையாது அப்படின்ற மாதிரி சொல்லுவோம். ஓகேங்களா, அந்த வெரி ஸ்மாலஸ்ட் கேட்டையான், இட் ஹேஸ் இஸ் அ மோர் போலரைசிங் பவர் வித் திஸ் பிக்கஸ்ட் ஆனையான். ஒரு எவ்வளோ பெரிய ஆனையானாக இருந்தாலும் என்ன கொடுத்துன்னா, ஒரு சின்ன கேட்டையான் என்ன கொடுத்துன்னா அது போலரைஸ் பண்ணிவிடும். நம்ம சொல்லுவோம் இல்லையா, ஆனையோட காதில் சின்னூண்டு எறும்பு பூந்துச்சுன்னா போதும், அது என்ன பண்ணிவிடும், அவ்வளோ பெரிய யானையே நிலகுலைஞ்சு போயிடும். அப்படின்ற மாதிரி இந்த பாசிட்டிவ் ஆன் என்ன பண்ணுவோம் அப்படின்னா, இந்த வெரி ஸ்மாலஸ்ட் பாசிட்டிவ் ஆன், ஓகே, இட் கேன் ஈஸிலி போலரைஸ் தட் நெகட்டிவ் அயான்ஸ். ஓகேங்களா, இந்த நெகட்டிவ் அயான்ஸ் என்ன பண்ணும் அப்படின்னு பார்த்தீங்கன்னா போலரைஸ் பண்ணி இப்படி என்ன பண்ணும் அப்படின்னு பார்த்தீங்கன்னா காம்பவுண்டை கிரியேட் பண்ணிடும். ஓகேங்களா, தென் அடிஷ்னலி தட் அயோடின் அயான் being the largest can be polarized to the greater the extent of lithium plus ions. ஓகேங்களா, அது என்ன அப்படி அதுனா அது முனைவருத்தப்படும் அப்படின்னு சொல்லுவாங்க. ஓகேங்களா, then the reaction with this, for example, now compare. That is a one more question asking in our JE and the NEET examination point of view. For example, lithium fluoride, lithium chloride, lithium bromide, and then lithium iodide. Lithium iodide, which among the following has this lowest colon character, least colon character? Okay, which one have this most colon character? Okay, the lithium iodide has this most colon character, lithium fluoride has this least colon character. Or there is which one has this most ionic character? Lithium fluoride has this most ionic character. Okay, lithium iodide has this least ionic character. Okay, because of here is a cation is the common one, but the size of the anion, the size of the compare the size of the anion, fluorine, chlorine, bromine, and then iodine. Okay, the size of the anions are differ, but the size of the cation is similar one. Okay, so the lithium fluoride has this most ionic character. Okay, least colon character. Lithium iodide has this least ionic character, most colon character. Listen carefully. Okay, now then next we are discuss about sodium fluoride, potassium fluoride, lithium fluoride, sodium fluoride, potassium fluoride, rubidium fluoride, cesium fluoride. Okay, which one they have this lithium fluoride? Which one has this most ionic character? Here this anion is the common one. Anion is the common one, but the size of the cations are differ. Okay, lithium has a very smallest size, cesium has the biggest size. According to the Fajans rule, the smallest anion, larger the cation, they can make a ionic compound. So the cesium fluoride is the most ionic character. Cesium fluoride is the most ionic character. Lithium fluoride has this least ionic character. Or write that increasing order or decreasing order of that ionic nature of that halides, salts. Okay, listen carefully. There definitely that is a one question asking in our AEEE or JE examinations and the NEET examination point of view. So that kind of the questions definitely asking in our annual exam also. So listen carefully. Next we are discuss about the reaction with liquid ammonia. Next now we can discuss about reaction with liquid ammonia. That alkali metals are dissolved in the liquid ammonia to give this a deep blue color solutions. Listen here, one of the very important thing, alkali metals are dissolved in liquid ammonia, very diluted ammonia solutions. Okay, alkali, listen carefully, that alkali metals dissolved in liquid ammonia, diluted ammonia solution, they can give a deep blue color solutions that are conducting in a natures. Okay, they act as a very good electrical conductors. Okay, that is a solution, that is a salt solution, they can be act as a good conductor. That alkali metals is dissolved in the liquid ammonia to give us a deep blue color solutions. Okay, that is act as a conducting in the nature. The conductivity is similar to this pure metals. Okay, the conductivity is similar for the pure metals. For example, the specific conductivity of mercury is 10 to the power of 4 ohm inverse. And then for the sodium liquid ammonia, okay, the sodium in liquid ammonia, the specific conductivity of sodium in the liquid ammonia is 0.5 into 10 to the power of 4 ohm inverse. Okay, so what is the meaning? The conductivity of metals. ஓகேங்களா, ஒரு மெட்டலோடைய கண்டக்டிவிட்டி எப்படி இருக்குமோ அதே மாதிரி என்ன இருக்குது அப்படின்னு பார்த்தீங்கன்னா, ஒரு மெட்டலை அமோனியா சொல்யூஷன்ஸில் டிசால்வ் பண்ணும் போதும் அதனோட கண்டக்டிவிட்டி நேரில் என்னவாக இருக்குது அப்படின்னு பார்த்தீங்கன்னா சேமாக இருக்குது அப்படின்னு சொல்கிறாங்க. ஓகே, லிசன் கேர்ஃபுல்லி. ஒரு எலமெண்ட்டோடைய ஒரு மெட்டல்ஸோடைய கண்டக்டிவிட்டி எப்படி இருக்குமோ அதே அளவுக்கு என்ன இருக்குது அப்படின்னா அந்த மெட்டலை நீங்கள் அமோனியாவில் டிசால்வ் பண்ணும் போதும் அதனோட கண்டக்டிவிட்டி ஒரே மாதிரி தான் இருக்குது அப்படின்னு சொல்கிறாங்க. Okay, this happens because the alkali metals atom readily lose its valence electrons. Okay, all the alkali metals are readily lose that electron from this outermost orbitals, valence orbitals. Okay, it is electrons in the solution ammonia. Okay, this happens. Okay, why? This act as a have a more specific conductivity. Most specific conductivity means, okay, alkali metal atom readily lose its valence electron in the ammonia solutions. Okay, 1 mark 2 mark questions கேட்பாங்க. Okay, why that the metals, alkali metals that dissolve in the ammonia, it is act as a very good conductor. Why? Okay, because of the alkali metal atom readily loses the valence electron in the ammonia solution, in the ammonia solutions. Both the cation and the electrons are ammoniated to give this ammoniated cation and then ammoniated anions. Okay, both this here. Okay, for example, the metal, there is a metal. Okay, they can be lost that electron from this outermost orbital, they can be produces M plus ion and then electrons, M plus ion and electrons. Okay, both the cation and the electron, both the cation and the electron are ammoniated to this give this ammoniated cation and then ammoniated anions. Okay, for examples. Okay, that and the x and y moles of ammonia molecules, there is a remaining this 2 moles of ammonia molecules. Okay, they react with the metals. Okay, they can produce ammoniated cation. It is nothing but this is we are called as an ammoniated cation. This is we are called as an ammoniated anions. So that ammoniated cation and then ammoniated anions are present this inside of that ammonical solutions, mean that inside of the solutions mean they act as a good conductors. We know that. Which is responsible for the conductivity? That ions are migration of free ions are responsible for the conductivity. We know that the migration of free ions are responsible for the conductivity. So it has this positive and then negative ions. That is ammoniated cation and then ammoniated anions are there in this inside of the solution. So it is act as a good conductor. Okay. So the blue color of the solution in this in solution is due to this ammoniated electrons which absorb the energy in the visible region of the light, and then thus there is important blue color up to these solutions. Okay, why that ammonical solution, the metal is dissolved in the liquid ammonia, why they can be exhibiting this a blue color mean they can be ammoniated cations are absorb that energy in the visible region of light and then impart to this blue color of that regions. Okay, the blue color of the solution is due to this ammoniated electrons. That is ammoniated electron which is the responsible for the color of that components. Okay, the ammoniated cation, it is not responsible for that color of that complex color of the solutions. Okay, there is ammoniated electron is the responsible for the color of that metal in this ammonia solutions. Okay, they absorb the energy in the visible region of light and then can be important blue color to these solutions. The solutions are paramagnetic. The solutions are, okay, the metal is dissolved in the ammonia solutions. Listen carefully, there is a very important topic. That is a metal is dissolved in the dilute solution. Metal is dissolved in the dilute solution of ammonia. They can be produces a blue color. It produces a blue color. Here this ammoniated cation and then ammoniated anions are formed in this inside of the solution. They are all act as a good conductor. Okay, they have a paramagnetic in nature. They have this a paramagnetic in nature. But that is a metal is dissolved in the concentrated. The metal is dissolved in the concentrated solution of ammonia. Okay, they can be produces a purple color of the solutions. Okay, there is a diamagnetic in nature. Diamagnetic in nature. Okay, the solutions are metal is dissolved in. The metal is dissolved in the dilute solution of ammonia. They can produce a blue color. Okay, this is a blue color solution. They can be containing ammoniated cation and then ammoniated electrons. Okay, the ammoniated electrons are responsible for the blue color of the solutions. They are all paramagnetic in nature. On the standing slowly liberate that hydrogen resulting in the formation of amides. Okay, if you can be listen here, that is a metal is dissolved in the ammonia. Okay, the slowly they can produce metal amides. And then they can slowly liberate that hydrogen gases. Okay, listen here, and standing the slowly liberate the hydrogens. அப்படியே இந்த சொல்யூஷனை ரொம்ப நேரம் நீங்கள் அப்படியே விட்டுட்டிங்கன்னா அந்த சொல்யூஷன்லேருந்து என்ன ஆகும் அப்படின்னா மெட்டல் அமைடு வந்து ஃபார்மேஷன் ஆகிட்டு ஹைட்ரஜன் கேஸ் கொஞ்சம் கொஞ்சமாக வெளியேற ஆரம்பிக்கும். Okay, there is a concentrated solution of the concentrated solution of, okay, the concentrated solution, the blue color change into the bronze color, blue color change into this bronze color, வெங்கல மாதிரி என்ன ஆகும் அப்படின்னா வெங்கல கலருக்கு மாற ஆரம்பிச்சிடும். ஓகேங்களா, and then becomes a diamagnetic nature, becomes that diamagnetic nature. Metal is the react with dilute ammonia னா நமக்கு என்ன ஃபார்மேஷன் ஆகுதுங்க, ப்ளூ கலர் ஃபார்மேஷன் ஆகும். அதுவே மெட்டல் வந்து கான்சன்ட்ரேட் அமோனியோட ரியாக்ட் பண்ணும்போது நமக்கு என்ன கிடைக்கும் அப்படின்னா பிரான்ஸ் கலர் கிடைக்கும். இது வந்து டயாமேக்னெட்டிக் நேச்சராக இருக்கும். அது பேராமேக்னெட்டிக் நேச்சர், இட் இஸ் எ டயாமேக்னெட்டிக் நேச்சர். தட் இஸ் அந்த டாபிக் இஸ் அ வெரி 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 இம்பார்ட்டன்ட் ஒன். லிசன் கேர்ஃபுல்லி. Okay, the next we are discuss about the reaction with the water. Okay, this is a concept already discussed about in our 10th standard and the 9th standard lessons. We know that. Okay, the metals are react with water. If they can be first step, if they can be produces metal oxides. Furtherly, they can be react with water. If they can be produces metal hydroxides. These are all the basic in nature. Metal hydroxides are basic in nature. If they can be liberated hydrogen. Simply we says that any kind of the metals that react with water, it they can be produces metal hydroxides and then liberate that hydrogen. For example, the lithium, sodium, potassium. Okay, these are all that explosively react with the water. It they can be produces lithium hydroxide, sodium hydroxide and then potassium hydroxides. They can be liberated hydrogen gases. Liberate that hydrogen gases. The hydrogen gases used to they can be burning of that materials. Okay, they also react with alcohols. They also react with alcohols and then alkynes which contains that is active hydrogens. Okay, the similar manner. Okay, how they can be, the metals are react with water, they can be liberated hydrogen. The similar manner metal also they react with the alcohols and then acetylenes, they can be liberated hydrogens. Okay, the sodium metal, if they can be react with the 2 moles of ethyl alcohol, if they can be liberated hydrogens. Okay, that acetylene, okay, it is one of the alkyne component. We know that it is the simplest alkyne component. We know that if they can be react with the sodium metal, if they can be liberate the hydrogens. Okay, next we are discuss about the reducing activity. That alkali metals can lose their valence electron readily, hence they act as a good reducing agent. Okay, the reducing property as the move the down the group is increases. The please note it. Okay, the reducing properties of alkali metals as the move the down the group is increases. Okay, the next reaction with the carbons. Okay, the lithium directly react with the carbon to form this ionic compounds. Lithium is directly react with the carbon. They can be formed this ionic compounds, ionic carbides. Okay, other metals do not react with the carbon directly. However, when they are all treated with the compounds like that, acetylene to form this acetylides. Okay, the lithium directly react with the carbon to form this ionic compounds like that lithium carbide. Other metals do not react with the carbon directly. This is one more question. Which among the following one of the alkali metal directly react with the carbon? Lithium, sodium, potassium. Okay, which is the metal? Lithium only, they can be directly react with the carbon. They can be produces a lithium carbide. So the metal carbides are ionic in nature. Okay, another metal do not react with the carbon directly. Carbon directly react pannadhu, but react pannadhu. However, they can be treated with this compounds like that acetylene to form this acetylides. Okay, now we are discuss about that. What are the important uses of alkali metals? What are the important uses of alkali metals? The lithium metal is used to the make useful alloys. The lithium metal is used to make the useful alloys. What is the alloys? There is a combination of 2 or more number of metals, that is here called as an alloys. For example, with the lead, it is can be used to making a white metals. Okay, the mixture of the lithium and the lead, they can be used to this making a white metal. Bearings for the motor engines. Okay, that is a very strong one. We know that. Okay, all the bearings. Okay, the white metal of bearing is the combination of lithium and lead. Okay, they used for the bearings in this motor engines. Within the aluminium, the lead within the aluminium to can be make a aircraft parts, and then within this magnesium to make a armor plates. Okay, it is used to this the thermonuclear reactors. Okay, listen here, the magnesium, which the metal is used to the make a alloy of armor plate, the magnesium is used to the making a armor plates. Okay, which is used for the thermonuclear reactors, the magnesium alloys is used for the thermonuclear reactors. The lithium is also used to the making a electrochemical cells. Okay, lithium ion batteries. Okay, lithium carbide batteries. Now we are nowadays we are using for that lithium batteries. Okay, nowadays mostly we are using for the lithium ion batteries. Okay, lithium carbide batteries. Okay, lithium is also used for making a electrochemical cells. The lithium carbonate is used for the medicines. Lithium carbonate, the zinc carbonate, these are all they can use it for this medicinal purpose. We know that. Okay, the sodium is also used in making a sodium and then lead alloys needed to make a tetraethyl lead and then tetramethyl lead. These are all organonated. Okay, there is a component organometallic compounds. We know that. Okay, where there is earlier used for the anti-knocking advices to this petrol, but nowadays lead free petrol only we are using them. Okay, they can be used to prevent that corrosion of that metals. Okay, inside of that engines, so we are using for that mixing with this tetraethyl lead in this inside of the petrols. Okay, the tetraethyl lead, that is act as the anti-knocking agent. This is a one mark questions. Okay, nowadays only the lead free petrol we are using them. Okay, mind it. Okay, the liquid sodium metal is used to this coolant in the fast breeder nuclear reactor. Okay, that is which the alloy is used for the fast breeder nuclear reactor. Coolant in the fast breeder nuclear reactor. Coolant நம்ம என்ன பண்றோம் பார்த்தீங்கன்னா குளிர்விக்கிறதுக்காக இந்த வேகமா பயன்படுத்தக்கூடிய அந்த நியூக்ளியர் ரியாக்டர்ஸ்ல நம்ம என்ன பண்றோம் பார்த்தீங்கன்னா lead sodium metals use பண்றோம். The potassium has vital role in this biological systems. The potassium has the vital role. Potassium chloride, potassium salt. The potassium salt is a very important things, but there is a very essential nutrition for that the growth of the plants. We know that. So there is a biological synthesis. Okay, the potassium chloride is also used for the fertilizers. Potassium hydroxide is used for the manufacture of soft soap. Okay, the sodium salt of that is a long chain higher fatty acid we are called as a hard soap. Potassium salt of long chain higher fatty acid we are called as a soft soap. Okay, the sodium hydroxide is dissolved in the oil, we get in this a hard soap. Potassium hydroxide is dissolved in the oil, we get in this a soft soap. That is nothing but bathing soap. Okay, it is also used for the excellent absorbent on the carbon dioxide. Then cesium is also used for the devising of that is a photoelectrical cells. The cesium also they can be used for the photoelectrical cells. Now we can discuss about some important general characteristics of compounds of alkali metals. Now we are discuss about that some important general characteristics of compound of alkali metals. All the common compounds are alkali metals are generally ionic in nature. Okay, the S block element is they can be combined with the P block element. They can be make a ionic compounds. Okay, general characteristics. Some their other compounds are. Okay, now can discuss about them. Oxides and then hydroxides. Oxides and then hydroxides. On combustion in the excess of air, alkali metal form this normal oxides. Okay, with the formula M2O. They react with the water to form this corresponding hydroxides, which is basic in nature. Already we are says them. Metal or first step they can be react with air, moisture air, they can produce metal oxides. Furtherly they can be react with okay metal hydroxides. Okay, that alkali metals apart from this lithium from this peroxide, that addition to this normal oxides upon the combustion within this excess of air. Okay, listen here, peroxides. The peroxides are react with water, they can be formed this metal hydroxides, and then same time they can be produces hydrogen peroxides. Listen here, the peroxide produces hydroxides and hydrogen peroxides upon the reacting with the water. Okay, what are they? We know that sodium, potassium, rubidium, cesium only they can be produces peroxides. The lithium does not produces peroxides. Already we are discussed about them. Okay, listen here, alkali metals. That all other alkali metals also form this superoxide also. The superoxide also, they react with the water. They can produces metal hydroxides and then hydrogen peroxide, water molecules. Listen here, normal oxides, mono-oxides, metal mono-oxides react with water. They can be produces only the metal hydroxides. The peroxides are react with water. They can produces metal hydroxides and hydrogen peroxides. The superoxides are react with water. They can be produces peroxides and then oxygen molecules and then metal hydroxides. Okay, under the appropriate conditions, the pure components like that monoxides, peroxides and then superoxide may be prepared. Okay, the properties of oxides and then hydroxides. Properties of oxides and hydroxides. The oxides and the peroxides are colorless in the pure state. Okay, the oxides, monoxides and then peroxides are colorless in this when in pure state, but the superoxides are yellow or orange color. Okay, the peroxides are diamagnetic. The peroxides are diamagnetic while the superoxides are paramagnetic. Okay, the peroxides are diamagnetic in nature. One more question. Okay, the superoxides are paramagnetic in nature. The sodium peroxide is widely used as an oxidizing agent. Which among the following one of the peroxide are usually widely used for the oxidizing agent? Sodium peroxide is used for the widely used for the oxidizing agent. The hydroxide which are obtained by the reaction of oxides within the water, all other white crystalline solids. Okay, all the metal hydroxides are white crystalline solid. They are all soluble in water. Okay, other alkali metal hydroxides are strong basic in nature. They are all easily soluble in water. They are all easily soluble in water. Dissolve in the water. Evolution of heat on the account to this intensive hydrations. Okay, there is they can be making exothermic reactions within this water. The metal hydroxides make the exothermic reaction within the water. The next we are discuss about the halides. Okay, alkali metal halides. Okay, metal halides, metal combined with the halogen. We know that it can be formed as metal halides. They are all colorless crystalline solid which has its highest melting point. They can be prepared by the reaction with this appropriate oxides. Okay, hydroxides or carbonates within this aqueous hydraulic acids. Okay, as the electropositive character of alkali metals increases from this lithium to cesium, we know that already we are discussed about them. The electropositive character is increases as the move down the group. Okay, the cases within this which in the metal form a halides increases from this lithium to cesium. Lithium to cesium in metals reactivity increases. All the halides are ionic in nature except lithium bromide and then lithium iodide. The lithium bromide and the lithium iodide are covalent character. The remaining alkyl halides, metal halides are ionic in nature except lithium fluoride. All other halides are soluble in water. Okay, which among the one of the metal halides is insoluble in water? It is a one mark question. So the lithium fluoride is insoluble in water. This is a low solubility because of lithium has a very smaller size. The fluorine also have a very smaller size. They have the strong electrostatic force of attraction which exists between the lithium plus ion and then F minus ion. Okay, we cannot be easily break them. The large amount of energy they can be need for that breaking that lithium plus ion and then F minus ion. So that has the highest lattice enthalpy due to the presence of covalent nature. Both lithium bromide and then lithium iodide are soluble in organic solvents. Okay, dear students, thank you for your cooperation. We are discussing about in our another topic, another video. Thank you for your cooperation.